Dear students, for today we'll see what do we mean by simulators. And in simulators, we'll see the definition of simulator, features of simulator, and then some of the prominent simulators which we use in day-to-day life. So let's start with the topic simulator. Now, simulator can be a device, a computer program, or a system which will allow you to imitate a real life experience, a real life procedure, a real life appliance, a real life effect. Say, for example, if you are learning how to fly an aeroplane and you are at the learning mode, so initially you can work on a simulator, on a model of that aeroplane, sitting in a room, looking at the screen. You can give all the instructions or commands, and that model will help you to see what happens when a particular instruction or a command is given, what happens to the plane, what happens to the aeroplane, how it is going, how it is moving. All those things you can study with a model without entering into an actual aeroplane. Because what happens in many of the cases, like flying aeroplanes, or you can have a nuclear fields, nuclear explosions, where you want to study things. If you go to do physically real inputs if you give, then you might go into a dangerous mode. You might waste time. You might waste money. It might be costly. Many things can happen. So instead of experimenting or studying into a real mode, you can study with the same model of that in a virtual mode. And there you can understand, you can study, you can give all types of inputs, all types of instructions, and see how the system works. And once you know everything, if you are perfect, then you can come to the real model or the real thing in life. Okay. So let's start with the definition of simulator. What is simulation? So before going to what is simulator, what do we mean by simulation actually? So here I have given a note. Simulation in general is pretending that one deals with real thing. It is pretending. It is actually a virtual thing, but it is pretending, it is making you feel that you are working with a real thing while really working with an imitation. Okay, so it is imitating the real thing. In operation research, the imitation is a computer model of the simulated reality. For example, a flight simulator on a PC is a computer model simulation of some aspects of a flight, that is aeroplane. It shows on the screen the controls and what the pilot, that is the person who is operating it, is supposed to see from the cockpit, that is his armchair, wherever he sits, whatever he can see, whatever he can control, what instructions he can give, what commands he can give. Instead of sitting in a real aeroplane, he can sit on a flight simulator and he can experiment all that. That will build up his knowledge, build up his study, build up his practice, and then he will become an experienced one. Then he can go and experiment that same thing in the real aeroplane. Then this is a picture what a flight simulator looks like. So here you can see the screen. So here you are seeing the screen of the flight simulator. Okay, and here you can have all your controls. Here you can have your controls. Here you can have your chair where you can sit, and you can control those things and experiment and see for every command, every instruction, every input, how the plane is going to make our response. This is also one way in which you can show a flight simulator. You can see the runway here on the screen, and you are having a simulator here. So this can be a simulator. Here you can control things. That control you can observe on this monitors. And then here you can see the outer screen where you can see the runway and other things, where you're going to fly, where you're going to take off or land the plane. Similarly, this is also one of the picture where you can show that the pilot and co-pilot can sit here, and here you can see the screens. These are the screens. Okay, and here is your control, and here you can monitor your control, and here is the armchair. Here also is a chair for the co-pilot and pilot. You can also have a simulator for a car driving, as I've shown in this picture. You can have a steering here, you can have a seat here, and you can have a monitor here, which will show you how the car is moving whenever you give any input, how you move the steering, how you press the accelerometer, how you press the brake. Everything you can study in a simulator model. So car driving also you can study. Here is one more picture where you can see the outer screen here, outer area of the car. You can have a steering, you can have all your controls, your gear systems and accelerator, brake, everything. You can have your chair here, and you can study how to drive a car. Then why to use these models? Whatever models we make of aeroplane or car or mechanical procedure or electronic circuit, whatever models we make, why should we use these models? Okay. Now here, as an example I've given, to fly a simulator is safer and cheaper than the real aeroplane. So running a simulator will be safer and cheaper than the real. So here we are taking example of airplane. So to fly a simulator is safer and cheaper than real airplane. For precisely this reason, models are used in industry, commerce, and the militaries. It is very costly, dangerous, or often impossible to make experiments with real systems like nuclear explosions. Nuclear explosions, you cannot go on the field and make real experiments. Instead of that, you make a model of that nuclear system, and then you experiment on the model on a computer based model, on a software, on a device. Simulation may be an effective alternative provided that the models are adequate descriptions of reality, and experimenting with them can save money, very important, can save sufferings, very important, and even saves time. When to use simulations? Now, for every real system, you are going to have a simulator, or when do you want a simulator? Systems which change with time, such as a example gas station where cars come and go, called dynamic systems, and involve randomness. Randomness means nobody can guess at exactly which time the next car should arrive at the station, are good candidates for simulations. So such things which are dynamic in their nature, which change with time, and which have randomness involved. You don't know if you give certain instruction what will happen next. So to answer all these questions, you can use simulations. Then we'll come to a point, what do we mean by simulator? Then as I have told you earlier also, a simulator is a device, or it can be a computer program or a system that performs simulation. A simulation is a method for implementing a model over time. So it is a time-based system. At every time, what instruction you give, what input you give, how it is going to behave in a real experience that you will get on a virtual mode by a simulator. A simulator is a program or machine that simulates a real life situation. A real life situation can be simulated virtually. Real life situation can be simulated, meaning that it creates a virtual version of it, often for the purpose of instruction or experiment. For example, flight simulators, as I've told you. Then you can see you can have simulators which can run circuits. You can take a simple circuit. So here we are showing a diode. This hub component you can take, and you can take an input, AC input. You can show the output across the resistor so that a diode can work as a rectifier, okay, or the diode can work as a switch. And that output you can connect to a CRO, And on CRO, you can see the waveforms. This is also a process of simulation where you are not getting actual input, where you are not having actual diode, where you are not having actual resistor, you are not having actual CRO, but everything is available in this software, which you can connect and run and see for various inputs how the diode is going to behave and what kind of outputs you will get. So without destroying any component, without consuming any power, you can study the circuit. This is also simulation. Here also you can see a mechanical procedure of a refrigeration. Okay, so here you can have your a compressor, a condenser, expansion valve, and evaporator. All those things, all are components you have here. So these components you can use and you can build up the process here. You can run the process and you can see all the parameters of the process. You can study the mechanical process of a refrigerating cycle by a simulator. So then we'll come to what will be the concept of simulator. Simulation is a technique that involves modeling a situation. First, you have to do the model of that situation and performing experiments on that model. A model is a program that imitates a physical process by use of a variable that can be manipulated. The model is used in simulation by causing it to respond mathematically to changing conditions as though it were the process of object itself. In simulation, the facility or process to be examined is called as the system of interest. So that is the system of interest in which you're interested, in which you want to see if you give what kind of inputs, what kind of instructions, what will be the output. Then what are the advantages of simulator? Okay, now you are not going into a real life this thing, a real life condition. You are bringing that real life on a virtual mode and you're experimenting. Then for that, what would be the advantages? Number one, it can avoid danger and loss of life. Number two, our conditions can be varied and outcomes investigated. Number three, our critical situations can be investigated. This is very important. Our critical situations, if you go on the field and experiments, it will become very dangerous, costly, time consuming. But here it can be investigated without risk. Fourth, it is cost effective. Fifth, simulations can be speed up, so behavior can be studied easily over a long period of time. Number six, simulations can be slowed down to study behavior more closely. These are some of the very important advantages of simulators. Then we'll see the features. There are many features of simulators from the software point of view and the system point of view, from electronic hardware point of view. There are many features. So we will just see these features one by one. Here, the first one says that simulator features, it defines the processor or processing device family as well as its various versions for the target system. It will monitor the detailed information of a source code part with labels and symbolic arguments as the execution goes on for each single step. It will provide the detailed information of the status of the RAM memory used and the ports which are simulated of the defined target system as the execution goes on for each single step. It will provide the detailed information of the status of peripheral devices, that is the input, output, or devices simulated assumed to be attached to the defined system. It provides the detailed information of the registers which are used as temporary memory as the execution goes on for each single step or for each single module. It can monitor the system response and determines the output, the throughput. The windows on the screen providing detailed information of the status of stacked memory, devices, ports simulated of the defined microcontroller system. It can show the program flow trace as the execution continues. It can show the trace the output of the contents of program counter versus the processor registers. This is at the hardware part. You can see it through the software. Trace of application software means an output of chosen variable in a function of stepping sequence. It helps the window on the screen to provide the detailed meaning of the present command. Whatever command you give, what is the meaning of that? Whatever input you are giving, what is the meaning of that? It can show on the window. It can monitor the detailed information of the simulator commands as these are entered from the keyboard or selected from the menu. It supports the conditions up to 8 or 16 or 32 conditions and unconditional breakpoints. Breakpoints and the trace together are very important for testing and debugging the tool. Facilitate synchronizing the internal peripherals and delays. It employs RTOS, that is real-time operating system scheduler, which is real-time operating system scheduler that preempts task. It simulates the inputs from the interrupts, the timers, ports, and peripherals. So it tests the codes for this. It provides network driver and device driver support. Now we will see some of the prominent simulation softwares which are used in day-to-day life. Some examples we have taken here. Number one is Matlab. Matlab you will be studying in your course. Number two is AnyLogic. Number three is Logisim. Number four is NS3, which is a network simulator. Number five is Immunes. Immunes means integrated multi-protocol network emulator or simulator. Number six is OpenSim, which is a tool for modeling and simulation. Number seven is Open Simulator, which is an open source, multi-platform, multi-user 3D application server. Number eight, MultiSim. MultiSim also you will be learning in your course for PCB designing. So all these are some of the names of a prominent simulation software. These names in a little detail we'll see. What is Matlab? Matlab is the language of a technical or computing, is a programming environment for algorithm development, data analysis, visualization, and numeric or computation. So it is mathematical lab, which is short formed as MATLAB. Simulink is a graphical environment for simulation and model-based design for multi-domain dynamic and embedded systems. MATLAB and Simulink are also fundamental teaching. This can be used as a teaching in the teaching purpose also, and it can be used in research tools also in the world's universities and learning institutes. Then you can have the next one as AnyLogic. It is also a simulation modeling, provides a safe way to test and explore different what happens if. So what if scenarios, these are called as what if scenario. If I give the particular instruction input, what will happen? What if that thing is made, that thing is given, that input is given, that instruction is given, what will happen? These are called as what if scenarios. Make the right decision before making real world changes. Virtual experiments with simulation models are less expensive and take less time than experiments with real assets. Then we'll come to Logisim. Logisim is an educational tool for designing and simulating digital logic circuits. If you want to design and work the processing of digital logic circuits, then you can use Logisim. With its simple toolbar interface and simulation of circuits as you build them, it is simple enough to facilitate learning the most basic concepts related to logic circuits. With the capacity to build larger circuits from smaller sub-circuits and to draw bundles of wires and single mouse drag, Logisim can be used and is used to design and simulate entire CPUs for educational purposes. Then we'll see NS3, that was the network simulator. It is computer networking simulator. So NS3 is a discrete event network simulator for internet systems, targeted primarily for research and educational use. NS3 is free software license under the GNU GPL version 2 license and is publicly available for research, development, and use. Then we'll see Immune's integrated multi-protocol network emulator simulator, a realistic network topology, emulation simulation, hardware software framework based on the free BSD and Linux operating system kernel, partitioned into multiple lightweight virtual nodes, which can be interconnected via a kernel level links to form arbitrary complex network topologies. So this is used in our networking, and it can give you a emulator and simulator uh, process. Then you can have OpenSim, which is a tool for modeling and simulation. OpenSim is a powerful and freely available tool for modeling and simulation of movement. OpenSim can be used to help plan surgery for children. So you can have medical applications, like you can have surgery for children by this simulator without risking a life, and you can study what can happen. You have open simulators. It is open source multi-platform, multi-user 3D application server. It is an open source multi-platform, multi-user 3D application server. It can be used to create a virtual environment or world which can be accessed through a variety of clients on multiple protocols. It also has an optional facility, the hypergrid, to allow users to visit other open simulators installations across the web from their home. Open simulator installations. In this way, it is basis of nascent distributed metaverse. Then we'll see what is multisim. Multisim is one which can be used in your educational process for running or for processing circuits which are analog and digital circuits. You can run them, and for various inputs, you can see the various outputs, what kind of outputs it can get, and what are the limitations of the circuit. So Multisim is industry standard SPICE simulation and circuit design software for analog and digital and power electronics in education and research processes. Multisim integrates industry standard SPICE simulation with an interactive schematic environment to instantly visualize and analyze electronic circuit behavior. This is important. This you will be studying when you make a circuit on a software called as Multisim, and then when you run the circuit, and with the circuit you can make the PCB also afterwards. Multisim has an intuitive interface that helps educators reinforce circuit theory and improves retention of the theory throughout the engineering or curriculum. Researchers and designers use Multisim to reduce PCB prototype iterations and save development costs by adding powerful circuit simulation and analysis to the design flow. So as an example, we will see here in the Multisim software, you can build up a circuit as shown here, and the circuit output can be seen on the CRO, and the CRO waveforms can be studied. Okay, so here we have shown the circuit. So here you can see, here is the circuit shown. This is the circuit. This is the circuit which have taken the components from the library which is available in the software, and you can connect it with the you have connected them with the wires, and then you have taken all the equipments also, and here you have shown a CRO which is connected with the output, and that CRO can be made zoomed. It can be zoomed, and you can see the waveforms on the CRO correctly, what were the inputs and output waveforms. And in the process, you can study the circuit. You can study the circuit without destroying any component, without consuming any component wires or equipments. You can study, and if the studies goes well, if your experiments are fruitful, if it is satisfied, then you can go with the real circuit. Okay, this is what you can do with such softwares like Multisim. You can do simulation also, and once the circuit is verified, then you can go for a PCB design for the same circuit also. Okay, thank you, students.